Hello, my name is Yu-Chen. My main research area is ultrafine particle system and engineering and computational fluid dynamics, or CFD. In the past, our group has designed and built various novel fine particle synthesis reactor systems for ultrafine particle generation, such as a low-pressure flat flame chemical vapor deposition, or CFD system to make the reactor meeting our spatial needs and to save cost. We designed most of the components in these reactors. Also, to make their operation more efficiently, we added automation software and hardware so they can be operated semi or fully automatically. With the help of commercial CFD software ANSYS, we can easily create 3D models for each of our reactor or component and simulate their fluid flow, heat, and/or species mass transfer properties. These microscopic simulation results allow us to observe phenomena hidden within these systems and identify fluid thermal concentration related problems in the system that cannot be observed with our naked eyes or conveniently measured at multiple locations at any time. These detailed information such as velocity, temperature, particle trajectory, to name just a few, allowed us to further refine our designs so we can achieve much improved reactor designs. With experimental work and theoretical simulation running hand in hand, efficiently using latest technologies, in the strong manufacturing and electronics base in Taiwan. Together, they enable us to collaborate with the University of Notre Dame on the development of the next generation of a fully automated nucleic acid detection platform using custom designed biochips. Besides research, I'm more than delighted to be an instructor to many of the courses that I teach at the senior and the freshman level. For most of the courses that I teach, I try to incorporate these very powerful research tools that I use in my teaching so that my students can also be benefited and be equipped with these abilities. Most of them did not know what abilities they need to prepare ahead of time in college. So I always ask them to imagine into the future.
Imagine one day in your future job, your boss asks you to work on a team project related to Internet of Things or IoT, involving programming, novel product development, and/or management. You need also to prepare a technical report in English and solve all kinds of real-world problems your boss asks you to work on. Yes, we're talking about the set of core abilities everyone needs in the 21st century: communication, collaboration, critical thinking, and creativity. This is what our students will be asked to do frequently in their future jobs. Are you prepared with all of these core abilities? I did my school learning in the 20th century. Most of the time, we listened to the teacher on stage and prepared our class notes. To this day, this is called teacher-centered learning. Some teachers will drop a question and pick a few students to answer. We do individual learning most of the time. We had very few opportunities to do peer instruction, teamwork, group discussion, and creative work. When we graduated from school, personal computers and the internet brought so much change to this world. I still remember when I was in graduate school, I had to go to the library to search for information and Xerox book pages. Now I do my daily information search on the internet, on my PCs at home and at work. I can quickly find relevant information I needed without having to go to the library. Yes, there is a new world awaiting for my students. I must say, the old 20th century school training has given me the opportunity to collect a strong set of core abilities, but they are not complete. I started my teaching like my teachers, but very soon I found out it does not work for all my students. I'm a trained scientist, so not long after my first teaching day, I started my own research on teaching each course to reinvent, observe, analyze, define problems, explore possible solutions, analyze results, and refine my teaching approach till we have good student learning outcome. This pretty much covers the first 10 years of my teaching till I attended a problem-based learning or PBL workshop on campus. During the workshop, I was amazed at what PBL can do to transform the classroom into a student-centered learning environment. All students are given the key to learn and sharpen a set of pre-designed set of core abilities. In a typical PBL class, the teacher will first throw a real-world problem suitable to the level of the students. Students are divided into small groups and do group discussion in a teacher-guided steps, and later on, student self-guided steps. They will read, discuss, and recall experiences and knowledge learned before that are relevant to the problem, make necessary hypotheses, identify associated mechanisms. After that, they need to define new learning issues, which are what they haven't learned or experienced before, but are new knowledge or skills required to solve the problem. Each team member is assigned tasks or learning issues to work on. And at the end, they need to collaborate closely to integrate or combine to present their solution to the problem to an audience in an open setting, which may also be a product they've made, a process they've devised, or a project they've executed. In contrary to the 20th century teaching, in PBL, teachers are tutors guiding as a coach in the process. Yes, students are on the center stage performing. Teachers are the coach on the sideline. Students are given the full responsibilities to self-learn collaboratively in a problem-solving process. After 10 years of exploring, experimenting, and research on PBL, plus combining my scientific research background to my teaching in each course, I've gradually climbed up the teacher's learning ladder and learned to be a teacher I wanted to be. In a typical PBL classroom, what I frequently do is 20% of teaching, like giving out problems to be solved, and some hands-on mini lectures, sharing some starting information, tips, or basic skills, with students spending 80% of class hours climbing their own ladders of active learning. But make no mistake, I'm still learning each day on how to become a better teacher to each of my students. 10 years ago, I gave my first PBL speech to teachers on campus and from other universities. Now I've accidentally accumulated more than 200 lectures all over Taiwan. I also uncovered my strengths as a teacher from the famous book, Teach with Your Strengths, from the Gallup Incorporated. Since then, I've used what the book has guided me to use, at least top 5 of my strengths in teaching. This has been of tremendous help to me as a teacher, and I've also discovered my students' strengths and learned along the way to design PBL learning activities to help them acquire knowledge and skills related to their strengths into core abilities required in the real world. In this lab, student teams are given goals, a set of lab equipment and lab automation hardware and software that they've never used before, and programming instructions and questions for self-guided experiments, observation, analysis, and discussion. Here, the student teams are photographed together with their project managers and tasks assigned to each team members. Here, the student teams are busy working on self-directed tasks, with most of our teams getting to the final of the YZU campus-wide maker competition. Here, they are explaining their prototypes to the judges and the audience from all over the campus. These are the PowerPoint slides the student team has created for their final oral presentation. Each team member has to take turn presenting 3 minutes of the task that they are responsible. Here's another sample of the student PowerPoint slides. This is the 3D printed components the student team, one of the student team has created for mounting the touch panel of their Arduino component on the bicycle they are reinventing. This is the circuit wiring diagram of their Arduino and components that the student team has created on their own. And they are also self-learning all the information, all the knowledge and skills here. This is the APP created for their prototype project. Besides the senior course I presented earlier, we are also preparing the core abilities of our freshman students. In these pictures, students are working as makers, working on creative IoT projects. This slide shows one of the many programming projects they have undertaken in the freshman course. Lastly, allow me to share my discovery in teaching YZU University's students over the last 10 years using PBL method. From guiding and observing them doing PBL at different levels, I think I've uncovered talents hidden inside each of them. After seeing them completing something extraordinary that have exceeded their expectation, I had to raise the level of difficulty and bring more new tools or skills or goals into their learning each year. Through PBL, student teams demonstrated they are capable of project management, self-learning, creating prototypes, peer instruction, communicating with enthusiasm, performing eye-catching demonstrations. I must say I've seen one of the most magnificent sights of a classroom. I hope I have the opportunity to uncover your strengths in one of my classrooms. Thank you for your attention.